Now, this is the next type of differential equation. And in type 2, we're going to look at something called as a reducible to exact equation. And on the right hand side, I have written all the steps, but I don't want you to read all of them right now. As of now, we'll just go on solving this sample question. And while we solve the question, I will point out to the rules or the steps that I've written on the right hand side, and it will make better sense. So what we should do is we should go about solving this question, and solution for this problem goes like this. The first thing you will do is compare the given equation with standard form. And as usual, the standard form is m dx plus n dy. Okay, so let me write down m dx plus n dy equal to 0. So when we compare that, we're going to get this as m. Okay, now this one here is m and this is n. So let me write that m is equal to, this is 4xy plus 3y square minus x, and the value of n is going to be, I'll just multiply this x inside. So it is x square plus 2xy. Now once you find m and n by comparing with the standard form, next thing you will do is what? Dou m by dou y. It is partial differentiation of m with respect to y, and we'll get this value. So we have to treat x as a constant. So this 4x is a constant. We are only differentiating y. It's a partial differentiation. So the derivative of y is going to be 1, and you will get 4x as it is. And the derivative of 3y square is going to be just 6y, and derivative of x is going to be 0, right? And next I'll do dou n by dou x, right? We want to find dou m by dou y and dou n by dou x. This will become 2x, the derivative of x square, and derivative of 2y, where y is a constant, 2 is a constant, derivative of x is going to be 1. So the answer is going to be plus 2y. So I found out the value of dou m by dou y, and I found out the value of dou n by dou x. And for the exact equation, I'm sure you remember that for exact equation, you want dou m by dou y to be exactly same as dou n by dou x. But if you see here, they're definitely not equal. They're not matching. Okay. So now we are coming to a condition. Do you see? If these two are not equal. All right. And let me write down since, okay, I'm sure you can imagine, since dou m by dou y is not equal to dou n by dou x. Okay. Therefore, this is not an exact equation. Okay, that's for sure that this is the given equation is not an exact equation. So now when it is not exact equation, you can't write down the solution directly. Okay, and when that happens, when the equation turns out to be not exact, now what we'll do is we'll try to convert or try to make this equation exact. Okay, and to do that, we have some rules over here. And this is the first rule that I've written. There are precisely 4 rules. Okay, we're going to see them one by one. So as of now, we are looking at only the first rule. Okay, you can just read the lines here. Then check if the given equation can be reduced, if it can be converted to the exact form. Okay, by any of the following 4 rules. And this is the first rule we have. So we'll see how the first rule applies. Now what we'll do is, this is the condition. This is what we need to do right now. Okay, we have to do dou m by dou y minus dou n by dou x and divide that whole thing by n. All right. Look, we already have dou m by dou y here. We have dou n by dou x as well. Okay. We can simply minus that. Okay. So let us just work out this condition. Okay. For say dou m by dou y minus dou n by dou x divided by n. Okay. Now this is going to be equal to, okay, let me write that. Dou m by dou y is this value here. This is 4x plus 6y. Okay. Minus dou n by dou x is going to be 2x plus 2y, and we have to divide that by n. So the value of n is going to be this one here. So I'll divide by n. So you'll get x square plus 2xy. Now let us see how we can simplify this, and let's see what we get. So now this is 4x minus 2x is going to be 2x, and then 6y minus 2y is 4y. And let us simplify the denominator as well. I'm sure I can take this x common from the denominator. So you'll get x common out, and this is x plus 2y. Okay. And over here, do you see, I can also take 2 common, and then this 2 goes out, and this will become 2y. Okay. With that simplification, I have got x plus 2y, cancel out with x plus 2y, and I get 2 by x. Now, as soon as you find out this value, you have to check whether this here is a function of x or not. And look, 2 by x is purely made of x. And when it is purely of x, there should not be y, okay? It should be pure x function. And if that happens, it's a good news. All right, I'll tell you why. Because when you get a function of x or f of x as the answer of this thing, okay, you will find something called as if. And the full form of if is going to be integrating factor. Okay, I'll just show you how that works. Now we'll find integrating factor, and if is going to be e raised to integration f of x. We have this f of x over here. This is 2 by x dx. Okay, let us simplify this more. I can take that 2 out, e to the integration, e to the 2 integration 1 over x dx. Now we'll integrate this 1 by x and that will become log x. So this will be e raised to 2 log x. And look, I can always take this 2 over here. It's a log property, right? This term can really be power of x. So let me write that e raised to log x square. And then now e and log will just cancel each other out. And you're going to get this as x squared. So basically, I found the if, the integrating factor, to be x squared. Okay. Now, as soon as you find the integrating factor, we have reached till here. We have found the value of if. Now, next you'll find is something called as m dash and n dash. And that's pretty simple. What we do is we just multiply m with the if and n with the if. Look, we have already the values of m over here and the value of n is over here. And all we have to do is we just have to multiply this m with the if that we got, which is x squared, and we will get m dash. So let me write that m dash is going to be m multiplied with integrating factor. So let me write m. This is 4xy plus 3y square minus x. This is the value of m here. And you multiply that with the x square. So I'll multiply that with x square. Okay. And let's write that m dash properly. If I multiply this inside, it's going to be 4x cubed y. And then this will be plus 3 x square y square. Keep an alphabetical sequence. X comes first, y comes later. That just helps. Minus x cubed. So now this is going to be the value of m dash. All right. This is m dash. Similarly, we'll find n dash as well. For n dash, we'll have to multiply n with if. Okay. When I multiply n with if, this is going to be n value is x square plus 2xy, and if is x square over here. You see this? If is x square, and we'll multiply this. So you'll get x raised to 4 plus this is 2x cubed y, and this is the value of n dash. Okay. As soon as you find the values of m dash and n dash, now I want you to read this statement here. It says that whenever we find m dash and n dash, the m dash dx plus n dash dy equal to 0. Okay. The equation is 100% exact. Okay. You will surely find this equation to be exact. Okay. So as soon as you multiply this magic factor, okay, when you multiply by x square, your equation suddenly becomes exact. So it's a good thing, right? So I'll write down, therefore, okay, m dash dx plus n dash dy is equal to 0 is an exact equation. And when the equation is exact, the finding solution of an exact equation we already know from first time. We simply have to integrate with some conditions and we'll get the answer. So let me clear some space and let's complete this question real quick. The solution is going to be integration, m dash value is over here and n dash value is here. So it is integration, this is 4x cubed y plus 3x squared y squared minus x cubed dx plus integration of, okay, here we will treat y as a constant term and we will take n, which is free of x. I hope you remember that. So if you want n as a n dash, now n is n dash, right? So we want this to be a free of x and both the terms has got x in it. So we'll simply not take both of them. So we'll take this as 0 dy and the answer is going to be C. All right. Now we just have to integrate and we'll get the final answer. So the answer will be 4x cube is going to be, the integration here is going to be 4x raised to 4 by 4. Y is anyways constant. Now here again 3y square is constant. So you'll get 3x cube by 3. Y square is constant. And this will be minus x raised to 4 by 4. This was anyway 0. So right hand side is C. I'm sure we can simplify a few terms here. 4 cancels out. 3 cancels out. And then let's write down the final answer as x raised to 4y plus x cube y square minus x raised to 4 by 4 is equal to c. And this here is the solution of the differential equation. Okay, so how it is different than first time? In the first time, we immediately, when we solved, we got the partial derivative of these two were equal in type 1. But in type 2, they are not equal. Okay, if this is not equal, we say it is not exact equation. And when it is not exact equation, we can make it an exact equation. And to do that, we have 4 rules. Okay, the first rule is written over here. And in the next video, in the next section, we will see the rule 2, 3, and 4.